Welcome to PreMath. In this video, we have got this triangle ABC, as you can see in this diagram, such that two of its side lengths are 36 and 60 units respectively, and moreover this angle is x, this angle is 2x, and now we are going to calculate the area of this triangle ABC. Please don't forget to give a thumbs up and subscribe. Before we proceed any further, let me make it very clear that this figure may not be 100% true to the scale. Let's go ahead and get started. And here's our very first step. Let's go ahead and connect this point B with some point D on this line segment AC. Let's go ahead and connect that one such that this triangle ABD is an isosceles triangle. In other words, this side length AB is equal to this side length BD. If this is 36 units, this has got to be 36 units as well. And since this is an isosceles triangle, so this angle and this angle has got to be congruent as well. So that means this angle is going to be 2x. Therefore, this angle ADB turns out to be 2x. And here's our next step. Let's focus on this triangle BCD. And now let's recall exterior angle theorem. The exterior angle of a triangle is equal to the sum of two opposite interior angles, as you can see in this diagram. And here this is our exterior angle and these are our two opposite interior angles, such that C equals to A plus B. Therefore, in our case, this angle ADB is an exterior angle, and this is going to be the sum of these two opposite interior angles. If this angle is x, this has got to be x, such that if we add them, we are going to get 2x. So therefore, this angle CBD turns out to be x. Now we can see that these two angles are congruent. So therefore, this triangle BCD is an isosceles triangle. So therefore, this side length is going to be equal to this side length. If this side length is 36, this has got to be 36 units as well. So therefore, this BD and CD are equal to 36 units. And in this next step, let's draw a perpendicular from this point B onto this line segment AD. I'm going to call H, and here's our much nicer looking diagram. Now we can see that these two triangles AEB and BED are congruent triangles. Since this angle equal to this angle is 90 degrees, this angle has got to be 90 degrees as well. And if these two angles are same, then this angle has got to be congruent as well. So therefore, these two triangles are congruent. Therefore, this line segment AE is equal to this line segment ED. Let me call this line segment AE as an A, then ED is going to be A as well. Now let's focus on this triangle BEA. We know that this is a right triangle. Therefore, we are going to use the Pythagorean theorem. And here's the Pythagorean theorem, a square plus b square equal to c square. Let me go ahead and call this longest leg our side C. This one I'm going to call side A, and this side B. So let's go ahead and fill in the blanks in this Pythagorean formula. So A in our case is just simply a square, B in our case is h, so become h square equal to c is 36 square. So therefore, we got a square plus h square equal to 1296. Let's move this a square on the other side. So we're going to have h square equal to 1296 minus a square. Let me call this as our equation number 1. And now let's focus on this triangle BEC. Let's focus on this base. From this whole side length is going to be the sum of this A plus 36. So that's going to become A plus 36. Now we can see that this is a right triangle. So therefore we are going to use the Pythagorean theorem. And here's our Pythagorean theorem once again. A square plus b square equal to c square. Let me call this whole side, this one A, this one B, and this longest leg as C. Let's go ahead and fill in the blanks in this Pythagorean formula. So A in our case, A plus 36 whole square plus B in our case is H. So this becomes H square equal to 60 square. Let's go ahead and move this part on the other side. So we got H square equal to 60 square minus A plus 36 whole square. Now let's go ahead and simplify. H square equal to 3600 minus, and now let's recall this identity, A plus B whole square. We are going to apply over here. So this is going to give us A square plus 72A plus 1296. And here we have distributed this negative sign. So we got negative A square, negative 72A minus 1296. And here in this next step, I have combined these like terms. So I got this one. Let me call this as our equation number 2. And now let's go ahead and compare these equations 1 and 2. And here are our equations 1 and 2. Let's go ahead and compare them. Since the left hand side is same, so we can equate our right hand sides. So therefore we can write 1296 minus A square equal to 2304 minus A square minus 72A. Now we can see this negative A square and negative A square, they are gone. So we ended up with 1296 equal to 2304 minus 72A. Now let's move this negative 72A on the other side and 1296 on the other side as well, as you can see in this next step. So let's simplify furthermore. 72A turns out to be 1008. Now let's divide both sides by 72. So therefore our A value turns out to be 14 units. So therefore I'm going to replace this A by 14 and this A by 14 as well. And now we can see this whole distance AC is equal to the sum of this AE plus this ED and this DC. So let's go ahead and just write down AC is going to be 14 plus 14 plus 36. So therefore our length AC turns out to be 64 units. Therefore our this whole length AC turns out to be 64 units. Now in this next step, let's go ahead and calculate this height H. So therefore let's focus on this equation 1, and here I copied down this equation 1. And now let's replace this A by this A value equals to 14. So therefore we got H square equal to 1296 minus 14 square. So we got H square equal to 1296 minus 196. Let's take a square root on both sides to undo this square. So our H value turns out to be 10 times square root of 11. As you can see over here, I simplified this one. So thus our h value turns out to be 10 times square root of 11. So thus our h value, this one is 10 times square root of 11. And here's our final step. Let's go ahead and calculate the area of this triangle ABC. Now let's recall the area of a triangle formula. Area equals to a half time base time height. And in our case, our base AC is 64 units and our height is h equals to 10 times square root of 11. Let's go ahead and fill in the blanks. So area equals to a half times base, in our case is 64, and our height is 10 times square root of 11. And if we simplify this thing, area turns out to be 320 times square root of 11 square units, or in terms of decimal, our area is going to be approximately equal to 1061.32. And here's our final answer. Thanks for watching it. Please don't forget to subscribe to my channel for more exciting videos. Bye.